Hello, good afternoon. My name is Maria Sinta Della with ID 823124102. My study program, Mathematics Education. I from class A. I will start my presentation with the title LCM in the Indonesian KPK. Overview. Today's agenda. 1. Review the concept of multiply. 2. Understanding the meaning of LCM. 3. Finding the LCM using difference methods. 4. Reflection and the learning summary. Next, learning objective. After the lesson, students are expected to be able to 1. Explain the meaning of the least common multiply or LCM. 2. Find the LCM of two or more numbers. 3. Use the list of multiplies method and the prime factorization. 4. Solve contextual problem related to LCM. Okay, next. LCM. What is it? LCM. What and how to find it for beginners? LCM stands for least common multiply or the lowest common multiply. The LCM is the smallest multiply that is common to two or more numbers. Since we are dealing in multiplies, it won't be any surprise to know that for this we need to know our multiplication table. Okay, next. Let's say we have to find the LCM of 4 and 6. We are going to list multiplies of both these numbers, and we are looking for the smallest number that occurs in both lists. That common to both lists that the LCM not down multiplies of each number multiplies of both and just list them in a line. 4, 8, 12, 16, 20, 4, 24, and then list multiplies of 6, 12, 18, 4, 24, and done. You can see that 12 and 24 crop up in both listing. So their both is common multiplies, but the LCM means the lowest or least common multiplies, and the smallest number in word list in 12. Then we just say LCM of 12 and 6 is 12. That's pretty easy. Sometimes you will be given a set of 3 numbers and told to find the LCM. The LCM in that case, we just go track a set of multiplies for each of the numbers and find the lowest value and that common to all the 3 sets. Okay, next slide. Finding the LCM using prime factorization. If we have to find the LCM of example 12 and 32, we know we can list some multiplies and find the smallest value common to both numbers. So multiplies 48, 60, 74, 84, 72, 84, 96, and 108. and for 32, 64 and 96. So the LCM of the 12 and 32 equals 96. Next, now I'm going to use these same numbers to show you how to find the LCM using prime factorization. And the great things about this method is it works for any numbers of any size. First, we do the prime factorization of each of the number primes in red and composite number in blue. 12 is from 2 times 6. 6 is from 2 times 3. Circles times. And 32, 4 times 6, 4 times 8 is 20. Now 32, 4 is from 2 times 2. 8 is from 2 times 4. And 4 is from 2 times 2. Circle the primes. Okay, next we make a quick table of the prime factor. Using columns we made the like factors, leave a space where there's no match. 32 has the prime factor 2, 5 times with them in. 12 has the prime factor 2, twice I leave space and done, but is it remaining prime factor 3? I put a line under the prime factor to help my thing. Finally we find the prime factor of the LCM. We use one factor from every column, and if there's a vertical pair, we only take one of two factor. The LCM of this number is the product of this factor times 2 factor 2 times 2 times 2 times 2 times 2 times 3. Work it out. And 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 34, and 34 times 3 is 96. So the LCM of the 12 and 32 is 96. Okay, next. Okay guys, find the LCM of 15, 66 and 30 and 32. Using prime factorization, find the LCM on that number. My process: first we find the prime factorization of each of the numbers. 15 is from 3 times 5, circular lines, and 32 is from 4 times 8. Times 8, 4 is from 2 times 2, 8 is from 2 times 4, and 4 is from 2 times 2, circular lines. 66 is from 66 is from 11 times 6. 6 is from 2 times 3. Simple the primes as you have probably been doing already in school. Now set up the prime factors table and put the like factors in vertical columns. leave a space where there is no mate. When I set up this table, I have to order the numbers somehow, so I pick the number which has a course of the prime factor 2 because it generally ends up looking nearer 32 is to the power 5. It has the prime factor 2 5 times. Okay, 15 has the prime factor 3 and 5. 66 has the prime factor 2, 3, and 11. Notice how only factor the mates are in vertical columns. Everything else is in own columns. All the prime factor are left in the table. Now, so next I find the prime factor of our LCM on factor from its column to 2 times 2 times 2 times 2 times 2 times 2 times 3 times 5 times 11, and now we work out the value of our LCM as shown by the prime factor we have here. 2 times 2 is it 4 times 2 is it 8 times 2 is 16 times 2 is 32 times 3 is 60 no times 2 96 times 5 is 100 times 5 is for 100. Sorry guys, times 5 is 480 times 11 is 5280. So the LCM of 15, 32 and 66 is 5,000. Okay, 5,000 to 5,280. Okay, is it LCM? So the next slide, summary today's class. Today we learned about the least common multiplier or LCM. We reviewed the concept of multipliers and understood that LCM is the smallest common multiplier of two or more numbers. We practice finding the LCM using two methods, listing, multiplies, and prime factorization. Finally, we apply the concept of the LCM to real life situations, such as determining schedule that occur at the same time. Okay, that's all the presentation from me. Thank you. See you again. Bye bye. Bye guys.